So this is the view. This is the part that we're going to duplicate in the SolidWorks software. So I'm going to minimize this window and minimize this window in a way where I can have more space to work with. So just like that, right? All right, so last time we started off and I had made the bottom sketch. Unfortunately, since I had not saved it on a folder, I lost it. So very quickly, I'm going to replicate that sketch. So I'm going to go to sketch using the top plane. All right. So what I'm going to do is I'm going to do this silhouette, the bottom shape. So I'm going to try to make it as accurate as possible in terms of the shape, but I am not going to add dimensions yet. This is aligned. So I have this shape right here. Notice that the shape actually is shaded inside, meaning that this isn't a closed loop. If it wasn't shaded, it's open. One of these points is not touching each other. They're not coincident. So just make sure when you do have a sketch, it's always closed loop. Blue lines indicate that it's not completed yet. It's not fully constrained yet. So we need to constrain it. We need to add geometric constraints, which are, these right here, like vertical, horizontal. All of these are geometric constraints. Coincident constraints, right? Those are all geometric. Now, on top of that, after you do the geometric constraints, you want to add dimensional constraints. And this is what's going to make it more accurate. So this is actually 3.78. This should be 2.24. This should be 1. This should be 1.14. And this should also be 1. 3.78. Okay, everything's good. I got all of these. I need the 54 right here. So this is 54. 0.54. And this is 0.76. Then what else do I need? Believe that's it. Yeah. Now notice that this shape can still be skewed, and you want to check this before you do anything else. This line and this line should be aligned. They're aligned. So I'm going to hold the control key, select this line, and select this other line, and that is going to bring my geometric constraints or relations. And I'm going to say they need to be collinear. Collinear. And now they cannot be moved. Or if one of them is moved because it has a collinear constraint, the other one's going to move with it. You do not want this one to be collinear constrained with this one because this one's 76 and this one's 54. So when you're sketching, if you would have aligned it, it would have given you a collinear constraint, and that would have given you lots of errors. Now, I want to do the same thing again, try to skew it. Now notice that this sketch is still blue. It's not fully constrained, meaning it can be moved along the space. It can be skewed, possibly. So we need to pin it to the origin. What point should be pinned to the origin? Technically, it can be any. But if you took my intro class to SOLIDWORKS 139, you know that some points are more important than others. So coincident. Need to do the coincident. I'm going to make that coincident to that top corner. Now my sketch is black. Now it's fully constrained. Try to skew it, try to move it. It's impossible. So that's what you want, fully constrained sketch. You close the sketch using the arrow, not the X. Then I am going to extrude. So I'm going to extrude this. So extrude is what makes it a 3D part. So this profile is going to be extruded up, hence the command extrude boss. It's going to be extruded up. How far? Up 2 inches. And there you have your first solid model in SOLIDWORKS, or at least for this class. But then we're not finished. There's a lot of stuff to do in order for us to get this object here. And that's what SOLIDWORKS is good about. So notice that all of these cutouts are features. So this feature here, those I embedded it in the first sketch. Now to create this angled feature, I have to use this view right here. This surface is perpendicular to whatever sketch I'm going to draw. And I'm going to draw this profile and cut it. So I'm going to do this sketch, or a sketch onto this view, this plane, this surface. I'm going to do a sketch on that. So I select the surface and then I go to sketch. And then I'm in the sketch mode. Now I can draw. Notice that if I'm not perfectly horizontal, I don't get the horizontal geometric constraint. I want that geometric constraint, so I need to be perfectly horizontal, and then I need to be perfectly vertical. And if you are perfectly horizontal and perfectly vertical, look, it gives you those constraints. It's a closed sketch, closed loop, because it's shaded. I want this point and this point coincident. So I need to hold down my control key, click on this point, click on this point, and make them coincident. So coincident is my geometric constraint. I highly recommend to do geometric constraints before dimensional constraints. Always. That's a big note on your notebook too. And then 45 degrees. Dimension. Click on the line. Click on the other line. Dimension. 45 degrees. That's it. And then the distance from this corner to this edge right here, that is 0.74. I'm going to do another dimension. Click on the line. This line needs to measure 0.74. Notice it's fully constrained because it's pinned to a object, a non-floating object. This is coincident with a non-floating object. So meaning if I try to move it around, it's not because it's pinned, it's coincident with the corner of this object here. So I'm going to close the sketch. And I'm going to rotate it using my roller button. If I hold it, I can rotate my object. I'm not actually, let me take that back. I'm not rotating the object. I'm just rotating the view, my viewpoint. If that makes sense. This is still on the top plane. I'm just rotating how I see it. Now, sketch 2 needs to be removed. So this material needs to be removed right here. It's a wedge. So you're like slicing off a cheese, right? So extrude cut, and I'm gonna do through all. Boom. So little by little, I'm doing these features. And in GD&T, features is what is important, because features are what makes a part unique. For instance, this feature right here, maybe something goes in here, a pin that kind of centers this object. And if it wasn't for that, if this is not precisely placed in the right location, this feature does not work properly. And this part needs to be scrapped or rejected and turned back to the supplier to be reworked, etc., or just scrap it for metal, and that's expensive. So that's what GD&T is all about, focusing on features. So it's a little bit different from my other classes. I'm going to focus on features now. So this feature, this feature, this feature. Now I need this other feature and this feature. Oh, and this one here. So let's do this one. Notice that I can choose this one, this surface, or this surface. Any of these surfaces are good to actually remove the material. So I'm going to choose this one, sketch. Then, similarly to what I did last time, I'm going to do this right here. Horizontal constraint, vertical constraint. Closed loop. I'm good. Hold down the control key. Make them coincident. Now I have two black lines, or two lines that converted to black. So I'm almost there in terms of fully constrained sketch. Now I'm done with geometric constraints. Now I can move on to my dimensional constraints. And this is 45 degrees. And this distance from here to here, that should be 50. So 50 from this line to here. All right, perfect. Close it. Go to features, extrude cut. We are removing material through all. Yes. So 2 wedges, and it's looking very close. It's not looking very close. It's looking precisely what it should be. You don't want close enough parts, especially in GD&T. Let me do this one just to stay in the theme. But now I'm going to choose this surface because this one is perfectly vertical plane, and this one is at a slant. I don't want to use the slant surface to create my sketch. I want this vertical surface to create my sketch. Then this is going to be a little bit different. It's going to have something like this. So at the beginning, it's good to have just an approximation. It doesn't have to be perfectly the same. Bless you. What you do want to do is be proportionally there. Add your geometric constraints. Then your dimensional constraints. 30. And then this is 74. All right. Something's wrong. What is this? 30. What is the distance from? Okay. 1.12 from here to here. So 1.12. This from this point to this point. Notice it wasn't fully constrained, so it needed an extra dimensional constraint. Sometimes it could be that it needs a geometric constraint, and that's when parts start getting complicated and sketching starts getting a little bit fuzzy, complicated. And we have to work around SolidWorks, and sometimes it can be a pain in the butt. So let's close this sketch. Let's go to features, extrude cut. Notice it's parallel. If I would have chosen this surface to sketch it, it would have been like this, going down, and that's not what we want. Through wall. So I'm almost done. Now I need this feature right here. So this feature right here, I'm going to do a sketch onto this plane right here. Sketch. And then it's a circle. I can place it anywhere as long as it's near where I want it. Then geometric constraints, right? So it's a circle. Now dimensional constraints. The distance from here to here, I need to locate the center point of that circle. That is 0.76. And then this distance is 0.62. All right, perfect. Then this right here is diameter. That symbol right here is a circle with a diagonal sign, slash, right? That is a diameter symbol. And we're going to learn that symbol in your chapter homework. Diameter symbol 0.625. And for the constraint sketch, now I need to cut it. Cut this circle, make a hole 1.25 deep. So I'm going to go to features, extrude cut, not through all. It's going to go blind. It's a blind hole, and that is 1.25. That's how deep it should go. And we call it blind. So there's your blind hole right there. This distance from here to here is 1.25. And just like that, I have my complete, perfectly exact same part as this in 3D form using SolidWorks. Now, I should save this file, save, or just hit the icon, save icon. And this is the tool holder. Actually, I'm just going to say CA1. CA1 desktop for now. Save. Now that I have this part already created in 3D, I need to create a drawing off of it, right? Orthographic projection. I need to create the necessary views. This is a little bit complicated part, so I need 3 views. The front view, top view, and right side view. So let's do that. So I'm going to do a new And instead of doing a part, I'm going to do a drawing. Okay. Since I have my part open, it actually is going to automatically populate the information. See CA1? It's right there. High quality. You have selected a drawing document, only parts and assembly. Okay. Yeah, this one. Okay. Double click on the CA1. Now, it's a little bit too big. So let me see, default. Notice you can choose the views that you want, but I'm gonna drag them and place them there. Project it, high quality. Front view, where's the scale? All right, use custom scale. I want to use a smaller scale because it's too big. All right, right there. So this should be the front view, meaning looking at it from the front. So this is, let me see. This should be the front view. If it's this one, it's okay also. Let's see which one. No, this one should be the front view. Yes, front view. Top view. So the top view is as if you were looking at it from bird's eye view. And then right side view. So this is orthographic projection right here. And then I also like to have the isometric. They don't talk about that in the video, but I always do have the students put in the isometric view. So front view, top view, right side view. Now, we are going to add the dimensions that they give us. So in orthographic projection, you always want to add all of the dimensions. It says add all necessary notes on drawing. It should also say plus dimensions. So the notes is like this, and all of these dimensions to actually explain the feature. And that's what GD&T is all about. So this is basic dimensioning. And we're going to get into GD&T, which is more advanced dimensioning. So smart dimension. I'm going to do the 3.78 over here. I am going to do the 1 inch right here. I'm going to do the 1.14 right here. And the 1 right here. Notice it automatically staggered it. That's fine with me. Right now, it's just the introduction to orthographic projection. This is 0.54. Notice that some of these dimensions cannot be placed in other views, except for like right here. Like the 0.54 is not this from here to here. It's actually this distance right here, which cannot be seen here and cannot be seen here. So there's some views that are necessary, absolutely necessary. .76. The 30 degrees. It can only be represented here. 30 degrees. The 45 degrees can only be represented here. In this view, the right side view. And then there's another view, 45 degrees, this one. And we also need some distances. This distance from here to here. Oh, not that one. No. it changes when I set the dimension. Maybe I need to zoom in and do something like that. Yes. So zooming in, fixed it. So that's the 0.74. And I also need the 1.12. If you need some more space between your views, you can just drag on this box. All right, so I'm missing this one here, the 50. You always never want to be inside the drawing. Don't place it there, even though the example gives you the dimension there. But in actual true orthographic projection drawings, you do not want to be inside the part. Those are some of the rules that we're going to go over. Then, do I have this one, 74? Nope. Let me add this 74. And then, am I missing anything? I'm missing this one here, the position. The 0.76 from here to here. And the 0.62 from here to here. I am also missing the dimension call out, this one here. The size of the hole. So notice that it's a 0.625. So 3 decimal places in the tolerance position. And then also it has an extra note. It says 1.25 deep. That we have to manipulate the dimension box, the dimension text, by placing your cursor there, enter, and you're going to type in 1.25 deep. And a heads up, all of the text in your drawing should be capital letters. And this arrow or leader, this is the tail end of the leader. This should always point to the beginning of the dimension or to the end of the dimension. So let me count my dimensions. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 dimensions. Do I have 18 dimensions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm missing 2, which is the 0.7, no, the 2.24. Now, 2.24 can be here or here. Let me place it here. And then what else am I missing? 1.2, this one, 45. Oh, the height, 2 inches height. Okay. That's it. 18 dimensions. So this is your orthographic projection drawing. Front view, top view, right side view, fully dimensioned with the dimensions given, your isometric view, and we're not done yet. Sorry. We gotta add a note, our notes. What are the notes? This right here. CRS means cold rolled steel. notes. 1, cold rolled steel or material, abbreviate material, cold rolled steel. And then 2, 1 required quantity, abbreviated, 1 required. And I'm set. I'm done. Who drew it? M. Rosas. When? 8/31/22. Okay. All right. So want to center it a little bit more. Maybe I should get rid of the space between this right here. A little bit better. And then the date. Perfect. So there you go. Title, you don't need the title. If you want to add tool holder, it's perfectly fine. CA1 or classwork purposes is perfectly fine with me. Now, how are you going to turn this in? So you're going to print as a PDF, Microsoft Print to PDF. Okay. And you're going to call it CA1. Desktop. It's going to give you a PDF. So you're going to submit your 3D view. You're going to submit this drawing, which we're going to save it now too. Save this. CA1, save, desktop. So I have 3 files with the same name, CA1. Now, they're not going to replace each other because they're different formats. Let me show you what I mean. So 3CA1. This is my 3D part. This is my drawing. And this is my PDF. These 3 files you are going to upload onto your assignment, CA1. Just like that. I use the PDF so I can do some markings when you submit your assignment. So if you have any corrections, I'll mark them down and then you can just resubmit. So